going to go through some of the Math 3 Unit 6 Worksheet 6 problems on solving radical equations. So number 1, we are asked to solve the following for x. And the first thing we want to do is isolate the square root of x. So to do that, we are going to subtract 3 from both sides of the equation and end up with 4 root x plus 0 is equal to 12, and then divide by 4, and you end up with square root of x is equal to 3. And then you square both sides. So the square root of x times the square root of x is the absolute is x, and this equals 9. Next, on number 11, we have x minus 6 is equal to the square root of x. Square root's isolated, so what we're going to do is square both sides to remove that square root. And on the left side, it's x minus 6 times x minus 6. Which is 3x. And then distribute x times x times negative 6 times x, and negative 6 times negative 6. Set that equal to 3x. The negative 6x and negative 6x can combine. And because it's quadratic, we want to make the right side equal to 0, and then try solving it using one of the quadratic methods for solving. So I'm going to subtract 3x from both sides and get x squared minus 15x plus 36 is equal to 0. I'm going to try to factor this looking for two numbers whose product is 36 and whose sum is negative 15. Because the sum is negative and the product is positive, both would have to be negative answers. And you just start looking for using factors of 36. You can do negative 36 and negative 1, but that doesn't add to negative 15. Negative 18 and negative 2, again we don't get negative 15. Negative 3 and negative 12, which does give us negative 15, and so that's what we want. And so this factors to x minus 12 and x minus 3. Set each factor equal to 0 and solve. We end up with x is 12 and x is 3. But remember, we may have an extraneous solution, so we just need to check to make sure this works out. If x is 12, then we'd have, back to our very original one before we squared both sides, we'd have 12 minus 6 is equal to the square root of 3 times 12, or 6 is equal to the square root of 36. That's true. So we keep x equals 12, and then try x equals 3. Or should we just throw it out because we already got one? No, we need to check because it's possible that this one might work out. Let's try it out. 3 minus 6 is equal to the square root of 3 times 3, or negative 3 is equal to the square root of 9. This one is false, so yeah, we can throw this one out. We have an extraneous solution. Number 13. Here we square both sides, but actually we may want to think about this before we even do. Notice we're taking the absolute value of something, and we're taking the square root of something, and we're getting a negative answer, which is not possible. If you take the square root of a real number, you're not going to get a negative answer. So we can say no solution up front, or we can work through this and find that there is no solution. So let's work through this and see what would happen if you didn't recognize that. So square both sides, and you end up with 5 minus 4x is 9. Subtract 5 from both sides, and you get negative 4x equals 4. Divide by negative 4, and you get x is negative 1. So if we check this, we get the square root of 5 minus 4 times 1 is equal to negative 3. That would be the square root of 1 equals negative 3, which is false. And so we throw it out. There's no solution. Number 15. F of x, which is the square root of 1 minus x, minus g of x, which is x plus 1, in parentheses, when you put that, because that negative is going to be distributed to both, is equal to 0. I want my square root by itself, so I'm going to add the x plus 1 to both sides and get the square root of 1 minus x is x plus 1. Next, I'm going to square both sides. I get 1 minus x is equal to x plus 1 times x plus 1. Distribute, and you get 1 minus x is equal to x squared plus 2x plus 1. Make this equal to 0 by subtracting 1 and adding x to both sides. You get 0 is x squared plus 3x. Last factor and x out. And we end up with x equals 0 or x plus 3 equals 0, which is x equals negative 3. So we have two possible answers. Let's check to see if they work or not. So if we let x equal 0, we would get the square root of 1 minus 0 minus 0 plus 1 is equal to 0, which is true because 1 minus 1 is 0. So we keep x equals 0. If x equals negative 3, we would get the square root of 1 minus negative 3 minus negative 3 plus 1 equals 0. And that would be the square root of 4 minus negative 2 equals 0. Or 2 plus 2 equals 0, which is false. So we throw that one out and got one answer. Number 17, square both sides, and we end up with x squared plus 3 is x plus 1 times x plus 1. Distribute. You get x squared plus 3 is x squared plus x plus 1. I'm going to subtract x from both sides. X squared from both sides. And we get 3 is x plus x, which is 2x plus 1. Subtract 1. Divide by 2, and you end up with x is 1. Check it out. So if x is 1, we get the square root of 1 squared plus 3 is equal to 1 plus 1, or the square root of 4 is equal to 2, which is true. So we get to keep our answer. Number 3. Here we have, we want want to solve for x again, and so we want to get x to the 2/3 power by itself. So first divide by 5 and we get x to the 2/3 power is equal to 45 divided by 5, which is 9. And then to work through this, well, this means the cube root of x squared is equal to 9. And so to get rid of the cube root, we want to raise both sides to the 3rd power. So we get x squared is equal to 9 to the 3rd power. And then to get rid of your square, you take the square root, and so x is going to equal the square root of 9 to the 3rd, which is 9 to the 3/2. Or the square root of 9 to the 3rd, or you could write it as the square root of 9 first, then to the 3rd power, which is what we're going to use, because the square root of 9 is 3, and 3 to the 3rd is 27. Actually, I made a little mistake. The square root of x squared is not x, but it is the absolute value of x. So we have the absolute value of x equals 27, which means that x is going to either be positive or negative 27. On to number 5. Here we're plugging g inside of f, so we're taking the x minus 1 and replacing the x in this equation with that. And so that's going to look like this: f of g of x is going to be in parentheses x minus 1 to the power of 3/2. And we see that that's equal to 27. So this means the square root of x minus 1 cubed is equal to 27. So to get rid of the square root, we're going to square both sides, and we end up with x minus 1 cubed is equal to 27 squared. And then to get rid of the cube, we're going to cube root both sides. So x minus 1 is equal to the cube root of 27 squared, which we can also write this way: the cube root of 27 first, and then square second, which is easier to work with because the cube root of 27 is 3, and 3 squared is 9. So x minus 1 is 9. So add 1 to both sides, and we get x is 10. Next, look at number 7. Here we're going to add 6 first. So we add 6 to both sides, and we get x plus 4 to the 3/4 is equal to 21 plus 6, which is 27. X to the 3/4 means the 4th root of x plus 4 to the 3rd. And so we're going to raise both sides to the 4th power. And we end up with x plus 4 cubed is equal to 27 to the 4th power. And then to get rid of the cube, we're going to take the cube root of both sides. And we end up with x plus 4 is equal to the cube root of 27. And I'm going to move the 4th power to the outside, because it's easier to take the cube root of 27 than to take to raise 27 to the 4th power. And that is going to be 3 to the 4th power, which is 81. So x plus 4 equals 81. So x is going to be 81 minus 4, which is 77. Next, number 9, we're asked to solve the following for x and then to check for extraneous solutions. So here we have our square root already by itself, so to get rid of that square root we're going to square both sides. And so x plus 3 is equal to x plus 1 times x plus 1. Distribute, so x times x, x times 1, 1 times x, 1 times 1. And then we're going to add our two x's, so x plus 3 is equal to x squared plus 2x plus 1. And this is quadratic because the highest power is 2, and so our technique to solve this is to get one side equal to 0. So I'm going to subtract x and subtract 3 from both sides of the equation and get 0 is equal to x squared plus x minus 2. We're going to try to factor this. So 0 is equal to, we're looking for two numbers whose product is negative 2 and whose sum is 1. The negative 2's comes from the constant here times the leading coefficient, so 1 times negative 2 gives us the negative 2, and the sum comes from the coefficient of x, which is 1. So if we think through this, 2 and negative 1 would be our answers, and so we can factor this to x plus 2 times x minus 1. Set each of these equal to 0. And solve. And we get x is negative 2 and x is positive 1. And we need to check for extraneous solutions. So if we go back to the original and check x equals negative 2, we get the square root of negative 2 plus 3 equals negative 2 plus 1, which would be the square root of 1 equals negative 1, and that's false. So we got to throw out x equals negative 2, and then we could check it with x equals 1. We would get the square root of 1 plus 3 is equal to 1 plus 1, or the square root of 4 is equal to 2, and that's true, so we keep that answer. So x equals 1. Make sure you, when you work through these kinds of problems, especially if you get two answers, that you check both of them. Sometimes they'll both be right, sometimes they'll both be wrong, sometimes one will be right, one will be wrong. There's no way to tell until you check.